Nice launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Hello everyone, you are looking at a live view of Falcon Heavy on historic Launch Complex 39A at Kennedy Space Center, awaiting liftoff at 8:26 p.m. Eastern Time. Welcome back to our live webcast of the ViaSat-3 America's mission from SpaceX headquarters here in Hawthorne, California. My name is Atticus Videra, and I'm a propulsion engineer here at SpaceX. Now, if you joined us on Friday, you know we did get roughly to T-minus 59 seconds in the count when the vehicle called an abort. Aborts are a standard part of the countdown process. If the vehicle sees anything that's even slightly off, it'll abort the countdown to give teams on the ground extra time to review any potential issues before flight. The teams did work through these checks, and the vehicle and payloads are healthy. We are now looking forward to liftoff just a few minutes from now. Today we have 3 payloads on the mission. Those are ViaSat-3 as the primary payload for our customer ViaSat. ViaSat-3 is expected to be the world's highest capacity satellite and will be the largest all-electric satellite ever to be launched. In addition to ViaSat-3, we also have 2 secondary payloads on board the second stage. Those 2 payloads are Astronis' micro-geo satellite and Gravity's CubeSat Gravity Space 1. Both are scheduled to deploy after ViaSat, which will be a few hours after liftoff. And as we mentioned during our last attempt, for this mission, we do need a lot of extra performance to help deliver these satellites to their final destination in a geostationary orbit high above the surface of the Earth. In order to do this, we will not be recovering the side boosters or the center core, and instead each will burn the fuel that we typically use for landing. Now, because we're not recovering the boosters or center core, there's no need for landing legs, which you'll notice on the bottom of your screen there have been removed. We've also removed the grid fins, and this is just to save a little bit of mass for some extra performance on the vehicle. Our Merlin vacuum engine today will light 3 times during this mission. The last burn will take place around the T+4 hour and 20-minute mark into flight. Deployments will wrap up about 25 minutes after the final burn, and that makes our mission duration for today just under 5 hours. At T-minus 10 minutes and 48 seconds, systems are currently a go for an on-time liftoff. The vehicle is nearly fully loaded with propellants, the range is green and ready to support. Now, if for some reason we do not launch today, we do have a backup opportunity tomorrow at the same time. Now at T-minus 10 minutes and 30 seconds and counting, let's take a closer look at the Falcon Heavy vehicle.
Hey everyone, I am Jessie Anderson, a production engineering manager here at SpaceX. Falcon Heavy is a 2-stage vehicle just like Falcon 9, but the first stage of Falcon Heavy uses 3 boosters, whereas Falcon 9 only has 1. You can think of Falcon Heavy as essentially 3 Falcon 9 rockets strapped together, which means that it can carry much larger payloads. Each side booster has flown before, one booster having flown twice and the other 7 times before. The center core is new, but as Atticus mentioned, we won't be attempting to recover our side boosters or center core on today's mission. Falcon Heavy has 28 engines total. Each one of Falcon Heavy's boosters has 9 Merlin 1D engines, making for a total of 27 engines across all 3 boosters, and you can see that incredible view on your screen. At full power, these 27 engines produce the same thrust as 18 747 airplanes at takeoff. The 27th engine is a Merlin vacuum engine on the second stage and will power the payload to its final targeted orbit. Once the first and second stage separate, the second stage will propel our payload to its intended orbit. You'll notice some gray paint on the second stage today, and that's just to help absorb some of the heat from the sun to keep our fuel warm during the long flight today. And above the second stage is where our payloads are safely enclosed inside of the fairing, and that's what you're seeing there on your screen. The fairing protects the payload from aerothermal loads, heating, and contamination during ascent. Once we reach the vacuum of space, we no longer need this protection, so we will jettison the fairing as the second stage continues on its journey to orbit. We will be attempting to recover the fairing halves today with our recovery vessel named Doug. And speaking of fairings, today's launch marks the 100th flight of a reflown payload fairing. The ViaSat-3 Americas mission also marks the very first Falcon Heavy to launch with flight-proven fairing halves. ViaSat-3 is the first of 3 satellites to make up a new global constellation. So here's more about today's mission and payload.
Every mission starts with a vision. Ours is simple and powerful. Break new ground in bringing connectivity where it's needed most.
At ViaSat, we attack very, very, very hard problems. But the harder the problem, the fewer people that can do that, and the more interesting it is to us.
The story of ViaSat as a whole is a great story. We enable connectivity.
We say connecting the world, but that has a number of different meanings depending upon the type of customer you are.
From an end user like you or me sitting at home needing connectivity to do our homework, or to the connected passenger in an aircraft, to the Vice President, the President of the United States.
Our government customers are global customers. They go wherever they're needed, and they want to have the same type of capabilities everywhere they go.
For over 35 years, we've worked tirelessly to get to where we are today, creating satellites with greater capacity to carry more data and handle higher speeds.
We've heard a lot of people say it's impossible to do what they're talking about doing at ViaSat. You know, a terabit satellite, it's not going to happen. And so I'm really excited to say that's not true.
In just a few minutes, we will launch the world's highest capacity single satellite into geostationary orbit.
With this launch day, we are entering the ViaSat-3 era. We have our first one going up over the Americas.
Flight 1 enables us to bring connectivity to the markets here in North America and in South America.
The exciting part of ViaSat-3 is the fact that it's not just one satellite.
By deploying 3 ViaSat-3s, we will have a near global network that can provide services to virtually the entire Earth. One of the features you'll notice is the very large solar arrays. These enable us to generate well over 25 plus kilowatts of electrical power on orbit. That allows us to generate huge amounts of capacity that is then usable on the ground.
The enormous capacity of ViaSat-3 isn't worth nearly as much if that capacity is stranded in areas where there's no demand.
Most of the people in the world only live in a very small fraction of the Earth. Yeah, we still want to be able to connect those people when they move from place to place.
ViaSat-3 is designed to move our capacity to where the demand is.
Our ability to move that bandwidth around and really service those dense spots, that's what our customers are looking for.
It's not just evolving, it's really like a revolution, making these big leaps in technology, and that's cool.
If you look at the progression from ViaSat-1 to ViaSat-2 to ViaSat-3, ViaSat-3 is actually the smallest satellite we've ever built, despite the fact that it's got multiples of capacity.
We took things that were twice the size of a human and brought it down to barely the size of a shoebox.
The satellite design process is no longer buy parts and boxes and hook them up. What we wanted was to invest in technology that can really scale. It's not just a new satellite design, it's a new way to build satellites.
We've had to reinvent all parts of the system.
I want to thank everybody at ViaSat for their role in what we're about to do today. And of course, I want to thank our partners at Boeing. We wouldn't be where we are today without their support.
Many of us have spent several years working on this ViaSat-3 Flight 1 America's satellite. Today is the day.
With the ViaSat-3 constellation, billions of people can access more of the world, unlocking opportunity for everyone, everywhere. Starting now.
Next up, in preparation for retraction, the clamp arms around the second stage will open, and then that truss structure next to the vehicle, known as the strongback, will start to retract away from the Falcon Heavy. You can see those clamp arms starting to open up underneath of the fairing on the second stage there. After this, the strongback will retract away from the vehicle, and this is to clear the way for ascent. Strongback is used to provide structural support as well as routing for fluids.
NY booster, LOX load complete.
As well as routing for fluids and power to the vehicle.
PY booster, LOX load complete.
We just heard LOX loading finished up on the PY booster. Next up at around T-minus 2 minutes, LOX loading will complete on the second stage. After LOX loading finishes loading onto the second stage, the entire vehicle will be completely full with 2.8 million pounds of propellant.
Center core, LOX load is complete.
Just hearing the various boosters finish up their LOX loading. Looks like quite a nice day down there in Cape Canaveral. Weather is much more cooperative for this attempt today. Now again, in just about 15 seconds, we will be completing LOX loading on the second stage, which will wrap up the propellant loading phase of our countdown.
Second stage, LOX load is complete.
And there it is. Falcon Heavy is now fully loaded with 2.8 million pounds of propellant. Coming up next, we should see some white clouds venting from the TE LOX line. This is completely normal and part of our closeout process. Following this, the vehicle will enter startup at T-minus 1 minute. This is when the onboard flight computers take control of the countdown. And shortly after the vehicle enters the startup phase, our LD or launch director should give the final go for launch. Let's listen in for those callouts.
Falcon Heavy is in startup.
There we go. Falcon Heavy has just entered the startup phase.
Go for launch.
And with confirmation of go for launch from our launch director, Falcon Heavy is ready to go to space at T-minus 37 seconds with the ViaSat-3 mission.
Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power and liftoff of ViaSat-3. Go ViaSat, go Falcon Heavy. M1D chamber pressure is nominal.
We are 30 seconds into flight under the power of 5 million pounds of thrust. Falcon Heavy is headed to space. Now we are throttling down our engines on those side boosters, and that's in preparation for Max Q.
Power into telemetry nominal.
Max Q is the moment of peak mechanical stress.
Falcon Heavy is supersonic.
Peak mechanical stress on the vehicle, so we do slow down the vehicle to get through this period of high stress. And once we pass through Max Q, we will throttle those engines back up on those side boosters.
Max Q.
And great call out, we have passed through Max Q. So we're going to throttle up those engines again on these side boosters. You can follow along the telemetry on your left hand, on the bottom left hand of your screen. You can see the speed and the altitude of the vehicle. And some incredible views of Falcon Heavy in flight. Now, 2 minutes into flight, we will reduce the thrust on the two side boosters again, and that will be to decrease the forces on the vehicle structure. And that's because the vehicle is now lighter as we're burning through the fuel on the vehicle, but the thrust will remain constant. And wow, that looks amazing on the screen. All three boosters burning bright there.
Falcon Heavy is following a nominal trajectory.
And good call out on trajectory. Now again, we're going to throttle down the side boosters, and then the next event coming up in about a minute or just under a minute will be BECO. That's booster engine cutoff. That's where we will shut down the engines on the side boosters, and then we will separate the side boosters from the center core. And as a reminder, we are not landing our side boosters or center core today due to performance needed on today's mission. And you can see on your right-hand screen, we do have a view of the separation mechanisms from the center core to the side boosters. And BECO, or booster engine cutoff, is coming up here in a few seconds.
MVAC engine chill has started. Booster engine cutoff.
Side booster separation confirmed. Both side boosters, FTS has safed.
Great views there. We had BECO, booster engine cutoff, and we watched as those side boosters, and you could see them there on your screen, those side boosters falling
Vehicle
away.
is following a nominal trajectory.
Falling away from Falcon Heavy's center core. Awesome views. That's going to wrap it up for the side boosters today. The next event coming up here in about 30 seconds or so is main engine cutoff. That is also called MECO, and that will be on the center core, followed by stage separation and then the startup of our second stage engine.
Main engine cutoff.
Stage separation confirmed. Stage 1 FTS has safed.
MVAC ignition. Acquisition signal, Bermuda.
And we got some great views. We watched MECO as the engines on the center core shut down, stage separation, and now you can see on your screen that the MVAC engine has ignited. Now we are coming up on fairing separation.
Fairing separation confirmed.
And also we're able to see and hear the call out that
Stage 2 is following a nominal trajectory.
That the fairing halves have separated. They are now falling back down to Earth, and we will attempt to recover them using our recovery vessel, Doug. Now what you're looking at on your screen is a view on our second stage, looking aft at our MVAC engine. And our MVAC engine on the second stage is currently in the middle of its first burn. This burn has about a minute and a half left. After that, we'll have an additional 2 burns of our second stage engine before payload deployment. On your left-hand screen, you could see a map of the mission trajectory. And on your right-hand screen is a live view of the MVAC engine. As a reminder, our main payload for today's...
Stage 2 continues to follow a nominal trajectory.
Good call-outs. Our main payload for today's mission is ViaSat-3, and we do have 2 secondary payloads on board as well from Gravity and Astronis. That is the Gravity Space 1 and Astronis's micro-geo satellite. If you're just now joining us, we're currently in the middle of the first of 3 burns for this MVAC engine today. The next event coming up is in just under a minute and 15 seconds. We will have SECO 1, or what we call second engine cutoff 1. And that will end the first of those 3 burns. Today's mission marks SpaceX's 28th launch this year, 227th overall mission to date, and our 5th operational Falcon Heavy mission.
Stage 2, FTS has safed.
Now on your right-hand screen, you can see the MVAC engine.
Stage 2 has entered terminal guidance.
And we're getting good call-outs there. On the bottom right-hand of your screen, you can see the speed of the second stage as well as the altitude. And we are about 20 seconds or so from SECO 1. That's where we will shut down this MVAC engine and allow the vehicle to coast with the payloads on board.
Expected loss of signal, Cape.
And you could see that MVAC engine beginning to shut down. We did hear a call out for expected loss of signal.
Nominal parking orbit.
And we got confirmation of good orbit. So with confirmation of second engine cutoff and a good orbit, we'll be heading into a coast phase until our second relight of our MVAC engine around the T+30 minute mark. We'll come back to bring you live coverage of that second burn in about 20 minutes. So until then, sit back and enjoy the space tunes.
Suspected loss of signal, Bermuda.